So in the last video, we introduced the concept of intermolecular forces, talked about why they are important, and we introduced very, very briefly, at least the terms, the four types of intermolecular forces that a molecule could possibly experience, and the ones that we will talk about in this course. These four that are listed below here in order of increasing strength are dispersion forces, dipole-dipole forces, hydrogen bonding forces, and ion dipole force. And so I've written that. So the weakest one is first. So dispersion is the weakest. It is weaker than dipole-dipole. Dipole-dipole being stronger than dispersion, but weaker than hydrogen bonding, and so forth. So the strongest intermolecular force we will talk about is ion dipole. But let's start with dispersion forces, and before we talk about that, let's review this concept of polarity and dipoles, because that concept is going to be important when talking about dispersion forces and also with dipole-dipole as well. So if you remember in the chapter about Lewis dot structures, we introduced this concept of polarity. And polarity, that doesn't mean this cute little polar bear here. When chemists talk about polarity, when we say something is polar, that means that there is a separation of charge in that covalent bond. And that separation of charge is due to something called the electronegativity of the atoms involved. So we said that in a covalent bond, those electrons between the two atoms are not shared equally. Some atoms, like oxygen, want to hog electrons more than others, like hydrogen. Hydrogen would much rather donate some of its electron density to oxygen than accept it. So atoms that have high values of electronegativity tend to have those electrons more in a covalent bond, and therefore the bond between, or the connection between those two atoms is uneven, and that uneven attraction forms something that is called a dipole. So for example, in this OH bond, more of the electron density in the oxygen, more of the electron density is by the oxygen than by the hydrogen. And I know that because oxygen is more electronegative than hydrogen based off of the electronegativity table that was in the Lewis dot structure chapter. So you'll want to review this concept of electronegativity and have your electronegativity table in front of you when doing these problems with regards to intermolecular forces, because the ones for dispersion force and dipole-dipole deal with being able to determine if a molecule has a dipole. So that means you need to know if that molecule or that bond is polar. So polar means uneven distribution of charge in a bond. So that's polarity again. How are we going to use that when talking about something called dispersion force? So dispersion force is based upon instantaneous or fleeting, or another word would be temporary, dipoles. So it depends upon temporary separation of charge in a substance. How are we going to determine if a dispersion force is present? Let's use helium as an example. You don't tend to think of helium as something that's polar, and it's not, but how can we use this concept of fleeting or instantaneous dipoles to explain dispersion forces? Let's say I have a super duper high powered camera, and I am able to very quickly take a picture of a helium atom at different time frames. Helium, you remember from the periodic table, helium has 2 protons, it has 2 neutrons, 2 electrons. And so let's say I take one picture, and in my picture of my helium atom, I've got my nucleus at the center, and I have my 1, 2 electrons that are shown as these dots here. And in this one picture, both of my electrons are kind of scattered on this side of the atom. Because remember, electrons are always moving. They're kind of in a region of space called an orbital. So let's say in one time I take a picture, both of my electrons are over here. I take a second picture at a different point of time. My electrons have moved a little more farther apart, so one electron's here and one electron's here. Let's say I take a third picture, and at this point in time, I have two of my electrons over on one side of the atom. I have no electrons on this side of the atom. So what this frame of 3 for helium illustrates is the possibility of a fleeting or temporary dipole, because you actually have in this helium atom an uneven distribution of charge, because you have both of the electrons for the helium. Remember, our electrons are negatively charged. I have 2 electrons on this side of the helium atom, no electrons on this side of the helium atom. Hey, so I have a dipole that's actually been produced in this helium atom. Now that dipole is going to not be, that dipole will be temporary, it will be fleeting because the electrons are going to be moving around. But that instantaneous dipole is important because it's that instantaneous dipole that generates the dispersion force. Because you can also imagine with this instantaneous dipole, if I have a frame like that for a helium atom, that can generate these weak attractions or these dispersion forces in between helium atoms. Okay? So dispersion forces, they depend upon instantaneous, fleeting, or temporary dipoles due to the movement of electrons. They are the weakest intermolecular force we will talk about. And since all molecules have electrons, all molecules experience dispersion forces. So I tell my students when doing problems with this chapter, if I give you a molecule and I ask you what intermolecular force is present, you can always say dispersion forces because they're present in all molecules. Now, the strength of a dispersion force in a molecule may be stronger in one than another. We'll talk about that in the next video. But from this video, what I want you to come away with is this definition of dispersion forces, knowing that it is due to temporary dipoles due to the movement of electrons in an atom or a molecule. It is the weakest intermolecular force, and that all molecules experience dispersion forces.